Boom! All right, folks, here we are again. We continue with our series, the CSEC AdMaths project. All right, we continuing our work on Unit 1. Let me just pull the syllabus here. And if you recall correctly, in the previous videos leading up to this one, we dealt with polynomials. We dealt with addition of polynomials, subtraction of polynomials, which is a pretty straightforward matter in that you just group the like terms together. The only difference at this level is that you simply have more terms and more powers. That's all. All right, so with the maths, you would be dealing with powers up to 2, maybe 3 for the most. And if you get a power in x cubed or y cubed, that would more than likely be in section 2. In AdMaths, however, very early in the game, you find yourself having to deal with powers up to powers of 4, as outlined in the syllabus here. So in this video, I want to start talking about division, right? Division and factorization. All right, so we'll go with factorization first, which is more or less two sides of the same coin. And you'll see exactly what I mean. When we talk about factorizing something, factorizing simply means to break it up into its constituent factors. You see how I slow down to say that, right? To break it up into the factors which constitute the original entity. So for example, if we have to factorize the number 24, we could factorize 24 as, let us say, 12 by 2. And then I realize 12 could factorize as well. So 12, in fact, let me go on the board with it. 24 is 12 by 2, all right? And then you see 12, you know 12 is 6 by 2. And then you have the original 2 here. And you know 6 is 3 by 2. That's the 6 by 2 by 2. So 2 by 2 by 2 is 2 cubed, which is 8. 8 by 3 is 24. So anytime we talk about factorizing something, that's basically it, right? And then we have what we refer to as prime factors. Prime factors, a prime number, if you remember, is a number that could be divided only by itself and 1. So let us say, if you try to factorize the number 11, the only possible answer for that is 11 by 1. If you try to factorize 13, 13 is 13 by 1. 17 is 17 by 1. 19 is 19 by 1. All right? Etc., etc., etc. So we going back to the foundation in terms of understanding what factorizing is, understanding that the factorization that we would have been doing it at the mathematics level, we now would expand it. So at the level of maths, we would factorize a regular expression, all right? And we would factorize a quadratic expression. And we know that the quadratic factorization is a special beast by itself that has its own rules and procedures. And that is one of the topics where people start to stick, and they start to feel as if the maths is a problem. So before I go any further, let me say at this point right now that if you're doing AdMaths and your quadratic factorization is still a problem, right, I would advise you very strongly to go back and practice it. Because if your regular factorization is a problem, where you're factorizing an expression to the power of 2, then when you have to factorize expressions to the power of 3 and to the power of 4, you know you're going to have problems. All right? So as we go forward with the division of polynomials and the factorization of polynomials, understand that if your regular factorization is weak, the responsibility is yours to go and fix that. All right? So as a student who would have bought the AdMaths project, my online platform, of course, you know you'd also have the maths, the road to January at this point, and of course at a later date we'll just change the name. But you'll have the maths platform as well, so you could go and check it out. All right, so before I get deep into it, let me give you a simple example of the difference between mathematics and additional mathematics. So at the level of maths, we know we have this thing called the difference of two squares. right? As I like to tell my students all the time, the difference of two squares is the easiest factorization that you will ever do in your life. All right, so let me do some quick examples. We know that if we have, let us say, x squared minus 1, we know that factorizing that by the difference of two squared is x minus 1 into x plus 1. All right, it doesn't matter which one you put first, x minus 1 by x plus 1. It's the same thing as x plus 1 multiplied by x minus 1. All right, I think that is the commutative property if I'm not mistaken. Right, so addition is commutative and multiplication is commutative. 2 plus 3 is 5, 3 plus 2 is 5. 2 multiplied by 3 is 6, 3 multiplied by 2 is 6. So when an operation is commutative, the order of the terms doesn't matter. Yeah? Right. So x squared minus 1 is x minus 1 and x plus 1. We know, for example, that p squared minus q squared will be p minus q. All right. P minus q into p plus q. All right. We know, for example, that let us see, 64 minus w squared is 8 minus w into 8 plus w, etc., etc. So you notice again at the ADMATS level, I just run into this. ADMATS is not the place where we're going to be explaining that, right? If you come to do ADMATS, we take it for granted that it could factorize the difference of two squares. Yeah? Now, if, for argument's sake, in an ADMATS exam and you get something like this. Let us say they ask you to factorize x to the power of 4 minus 1. In fact, no, let me shift it around. If they ask you to factorize 1 minus k to the power of 4, you add maths now, right? You're not doing maths anymore. What are you going to do? Now, there is no, you wouldn't find a whole page explaining this in any textbook, right? What you have to do at this point now is go back on your foundational knowledge of the difference of two squares and recognize that 1 minus k to the power of 4 is essentially 1 minus k squared into 1 plus k squared. Yeah? So you recognize that 4 is 2 squared. Good? And then when you have this, you realize here also that 1 minus k squared could also be factorized as the difference of two squares to give you 1 minus k into 1 plus k, which is the factorization of this. And then you multiply by 1 plus k squared, and that is your final answer. So you're seeing the difference here again between mathematics and additional mathematics. It is not just that the actual computation becomes more difficult. Sometimes the level is the same, but it just is a little longer. So you had to get accustomed to writing. You had to get accustomed to plenty writing. So all the people who like to take shortcuts at the level of mathematics, some of you will actually get away with it. Don't even think about trying that when you do that maths. Yeah? Right, so let me give you a little long version now. Again, and we could do the same thing with any of these. So if, for the sake of argument, they ask you, let us say, to factorize p to the power 4 minus q to the power 6. Q to the power 6? Nah, let me go with the same. Let me go minus 2 squared. You can get that. Right? I think they do these kinds of things at the level of pure maths in Form 6. But if you're doing add maths, you're supposed to be able to recognize these, and that is the level we're operating at here, right? We want it sharp, we want it clicking. So p4 minus q squared, again, difference of two squares. You have an even power here and an even power here. So that will be p squared minus q into p squared plus q. We can't go any further with that. All right? And let me take some space on the board here now. So if instead of 1 minus k to the power of 4, they ask us now to factorize, let us say, for the sake of argument, p to the power of 8 minus 1. You see where I'm going with this now, right? Again, difference of two squares simply because it is an even power of p. All right? So you get p, this is equal to p, sorry, let me write that over. So p, in fact, let me use the whole board. P8 minus 1 is p to the power of 4 minus 1 into p to the power of 4 plus 1. And of course, p to the 4 minus 1 is p squared minus 1 into p squared plus 1 into p to the power of 4 plus 1. And then p squared minus 1 is p minus 1 into p plus 1 into p squared plus 1 into p squared p to the power of 4 plus 1. All right? Now, you notice in these workings that I didn't try to factorize and add the sum of two squares. So in other words, you can't factorize x squared plus 1 or p squared plus q squared or 64 plus w squared or p to the 4 plus q squared. There's no factorization for the sum of two squares. So if you see the sum of two squares, don't even think of trying to factorize that. All right? The only factorization where the squares are concerned is the difference of two squares. And at the level of admaths, the least they're expecting you to be able to do is to be able to take this and get that. All right? So be prepared to factorize the difference of two squares for powers of 4 and below. So powers of 4, powers of 2. All right? Now, I'm going to do one thing here to close up this video. This part, I don't want you to hurt your head too much about it, but I'm just showing you how far we could stretch the maths if we really want to stretch it. Now, even though we generally apply the difference of two squares to even powers, we could get argumentative and apply it to odd powers as well. So for example, I could say, for the sake of pure argument, you know that some people like to argue for nothing? We could do that in maths too, right? So for the sake of pure argument, I could say to factorize, watch it, p to the power of 3 minus q to the power of 3. So instead of p squared minus q squared as I have here, I have p cubed minus q cubed. I could apply the same logic to an even power. So just like how we have p squared minus q squared is equal to p minus q into p plus q, I could say that p cubed minus q cubed is, watch it, p cubed minus q cubed, watch it now. All we do is divide the power by 2. So that would be p to the power of 3 over 2 minus q to the power of 3 over 2 into p to the power of 3 over 2 plus q to the power of 3 over 2. All right? So in other words, we could apply the concept of the difference of two squares to any difference, whether the difference is positive, whether the power is even or whether the power is odd. All right? Now, for the purposes of exams, they don't usually do this. So you would have to look very hard to find this in an exam. Yeah? But again, in my teaching, I like to throw these things out at students so that we could get them thinking. So in other words, that is not something to be intimidated by. That is not something to be scared of. All right? All you're doing is taking the core concept, the basic idea, and applying it to any similar situation. First of all, with even powers beyond 2. In the case of odd maths, you will only go as far as powers of 4. And then, of course, we go a little further now and apply it to odd powers. Yeah? So I will close off this video here. You know, sometimes as I try to make the videos short and snappy whenever I could. And yes, there will be instances where the videos will be a little longer. But if you're here, I trust that you're here because you want to learn, and that the length of a video wouldn't be a deterrent. The fact that the videos might always be the most exciting videos wouldn't be a deterrent as well. All right, so that will be it for this video. The next video we're gonna do, I'm gonna get straight into the actual long division of polynomials. We're gonna start with some simple examples, and then we go on to the harder examples where we're going up the powers of 4 as outlined in the CSEC Admaths syllabus.